Students, we study about the coupler, star coupler. Now we can see about the remaining one, that is called as T coupler. Talking about the T coupler. T coupler. T coupler is of two types. First one is 80/20 T coupler. Second one is called as 60/40 T coupler. So observe here one thing. 80/20 T coupler, if you take, looks like this. It is called as T coupler. It is called as port 1. It's called as port 2. It is called as port 3. Power P1, power P2, power P3. If you send 100 watts of power to this one, out of that 20% will comes here, 80% of power will appears across the port 2. That's why it is called as 80/20 T coupler. In the main branch, it gives 80% of the total power, and in the side branch, it gives 20% of its total power. This is said to be called as your 80/20 T coupler we are having. If you talk about the same thing as 60/40 means, obviously you knows that it will comes along with 60 and this comes along with 40. 60 as well as this is 40. So I hope everybody in the class understood this. Okay. So this is what said to be called as the T coupler we are having. Now in T coupler, I will show you the diagram. So this is, we study in the topic T coupler. T stands for transmitter. If you connect by the T coupler, we are having only one way communication only. R stands for the receiver. R stands for the receiver. The T coupler remains the same. This is simply transferring the information. See, it is transferring and that is receiving that in one. Transferring the power and those are receiving only. But it is not like the case in our star coupler. In star coupler, you can send that information from output side also, you get from the input side also will come. But it is only one side. One side in the sense means that in the forward direction, only in the one side which will transfer. That is the difference you find out between your star coupler and T coupler. So next important thing after this I will explain to you. Another one is nothing but an losses. So the first loss that we are calculating here is called as the your excess loss, and we are also calculating the remaining part of the losses also. I can explain you about all the losses. What is the excess loss, insertion loss, okay, directivity or crosstalk to you. So please see here carefully. Explaining you about the first loss called as excess loss. Excess loss is going to be given as 10 into log of input P1 upon output value P2 plus P3. I hope everybody in the class understood this. It is said to be called as the excess loss we are having. It is called as excess loss. In terms of dB. P out total is what the total output values you are having. P2 and P3 is the P out total. Two ports are there, P2 and P3. In the star coupler we studied P out T. What is the P out T? P out T is nothing but an which is completely called as output power we are having. Dekho bhaiya, after the excess loss we are discussing about the next one, which is called as the insertion loss. Which is called as insertion loss we are having. Insertion loss is calculated for port to port. Insertion loss for input port and output port, because we have two output ports. When you talk about insertion loss, we get it like this: 10 into log of input port is P1, output port is P2, P1 to P2 of base 10. So when you talk about the next another one, which is called as the insertion loss we are having, which is calculated from 1 to 3. Power from 1 to 3, that is equal to 10 into log of P1 by P3 we are having of base 10. So P1 by P3 of base 10 is present, which is called as the insertion loss we are having. So after writing about this one insertion loss, we can tell about the crosstalk. Your crosstalk is also called as the directivity we are having, which is going to be given as, see, main port is getting 20% and the remaining port is, main port is getting 80%, remaining port is getting 20%. That is nothing but an P3 by P1. So P3 by P1 in the sense means that is 20% get out of 100% by this one, it is called 0.2. Directivity or crosstalk is equal to 0.2, it is fixed. For which coupler? For a coupler called as it is 80 by 20 T coupler. This is equal to 0.4 for 60 by 40 T coupler. This is crosstalk or directivity we are having. After talking about this one, we can call it a split ratio. So split ratio I am writing, which is called as the split ratio, percentage of split ratio, that is given as P2 upon P2 plus P3 into 100. P2 upon P2 plus P3 into 100, which is called split ratio. This is completely about the your coupler called as T coupler. So please all of you copy this part. All of you copy this part. Once copying is completed, please put a message. Right. Next one. Talking about the fused coupler. See about the fused coupler. So when we write about the fused coupler, see here, I am taking two fibers, this is one fiber, another fiber, it is called as fiber 1, it is called fiber 2, fiber 1 and fiber 2. These two fibers are going to be fused here. When you fused these two fibers, then what happens is, connection is formed like this, fibers are fused. So you are going to be getting here, it is called as a port 1, it is port 1, port 3, port 4, port 2. Now talking about the fused quartz, it is going to be looks like this, fused coupler. This is the fused coupler we are having. So like this fused and the coupler will going to be changed like this. Your fused coupler is also called as a 2x2 star coupler. It is 2x2 star coupler, 2 inputs are there, 2 outputs are there, 2x2 star coupler, which is called as a fused coupler we are having, is called as 2x2 star coupler we are having. Okay. So power should be coupled in the forward direction only every time. We can have that power should be coupled in the forward direction. It is fused and this junction is called as fused junction. It is called as fused junction we are having. Power will always couples in the forward direction only bhaiya. This is called as P1, port 1 power. Reflected power will come outside P2. Power coupled in the forward direction, it is P3 and this value is equal to P4 we are having. So it is said to be called as the fused coupler we are having. Fused coupler is a 2x2 star coupler we are having, and that is what said to be called as your input power is given in Pin. In the port it is given as input power. It is called as first port, second port, it is called as third port, it is called as fourth port. Dear students, can you please tell me what are the excess loss? Start Nana. Excess loss is nothing but an 10 into log of input power. Input power is how much? P1. Total output power P3 plus P4. I hope you got it, of base 10. See, P3 plus P4. Total output power is P3 plus P4. Your P2 is not an output power, it is a backward power. Backward power in the sense means it is called as directivity, crosstalk or cross coupling, okay, or cross coupling. Excess loss. After excess loss we are talking about the next one called as insertion loss. By insertion loss will be varies from port to port. I am writing from 1 to 3 port. Come on, tell the formula. 10 into log of insertion loss. Insertion loss is equal to P1 by P3 of base 10. P1 by P3 of base 10. Talking about the same insertion loss, we are discussing about the insertion loss that is moving from 1 to 4, that is equal to 10 into log of value is equal to P1 by P4 of base 10, which is called as P1 by P4 of base 10. Next, after the insertion loss, we are going to be talking about the another important one, which is called as crosstalk. Your crosstalk is also called as directivity. that is equal to that of 10 into log of value is equal to P2 by P1. The only thing we can write P1 by P2 also, but P2 by P1 it indicates very clearly negative value will come. You write P1 by P2 you will get a positive value, but that also loss only, that is also loss. Negative sign indicates the loss because of writing P2 by P1. After writing the crosstalk we can tell about the next one, split ratio. So split ratio is also going to be called as coupling ratio. Your split ratio is also called as coupling ratio, also called as coupling ratio, is equal to. So when we talk about a split ratio or coupling ratio, we can tell like this, that is P3 divided by P3 plus P4 into 100%, or P4 divided by P3 plus P4 into 100%, into 100%. This is what said to be called as your fused coupler concept. Please, WDM is also there, I will explain in the class. When you talk about the WDM, I will explain the definitions of all these things. Excess loss definition, insertion loss definition, crosstalk definition and split ratio definitions to you. Please copy it. स्टार कपलर में लास्ट डायग्राम नॉट क्लियर. Write down the first point, excess loss, excess loss, first point, the excess loss which is defined as the ratio of the excess loss which is defined as the ratio of power input to total power output, total power output. Right. Next point, insertion loss. It is defined as loss obtained for a particular port to port optical path, particular port to port optical path, right. Next, put the heading as crosstalk, it provides a measure of directional isolation. It provides a measure of directional isolation achieved by the device directional isolation achieved by the device is the ratio of the backscattered power achieved by the device is the ratio of the backscattered power received at the second input port, backscattered power received at the second input port to the input power, second input port to the input power, second input port to the input power, second input port to the input power. Right. Next, split ratio or coupling ratio, split ratio or coupling ratio? First point, it indicates the percentage division. It indicates the percentage division. It indicates the percentage division of optical power between output ports, okay, right. See here, what is the last diagram of the star coupler, Bhaiya? Students are asking about that. Star coupler, last diagram of star coupler. I think this one. Yeah, see here. Whenever you are talking about this star coupler, from star coupler you are connecting, see, star coupler will have multiple ports. So, here you are connecting the one input, here connecting another output, here connecting another output, connecting to other networks. This is how they are connecting the networking. We have one coupler. For example, from here the power is coming, this power is distributing to the remaining all the ports also. That is what going on. If information is coming from this one, that information will passes to remaining all the ports, and what is the information given by the remaining ports will also going to be taken and passes to this one. That means bidirectional transmission is done either from input to output or from output to input, Bhaiya. That is what is said to be called as obtained in our star coupler we have. I hope everybody in the class understood this. Okay. So, this is about the star coupler value. So, students are asking about this diagram. So, I show it once again. If anybody is still copying also, you can please copy this part. Copy this part. Anybody is still copying, copy this part. It is a practical connectivity, how the star coupler has to be done, Bhaiya. That is the topic actually. Right. So, I hope copying is completed. Explaining you the next concept, that is called as polarization, the last topic in attenuation. So, we can right. Listen carefully. Later on you can copy this part, talking about the polarization. So, when we are talking about the polarization, I want to tell you one simple point. If you see here, cylindrical fibers, you need to see about the cylindrical fibers. This is how we are having a cylindrical fiber. Cylindrical fibers does not maintain circular symmetry, does not maintain circular symmetry. For that reason, we are having no polarization will be present. Okay. So, does not maintain circular symmetry, cylindrical fibers does not maintain circular symmetry. So, we does not have polarization, the polarization cannot be maintained for more amount of time. When this polarization is not maintained for more amount of time, so it does not have polarization, does not maintain for more amount of time. Why? Because it is not maintaining more amount of time, because the fiber is not symmetric, does not maintain circular symmetry. Designing become very difficult to maintain that much circular symmetry by here. That is why the polarization cannot be maintained. So, what are the light that is passing into a fiber does not maintain the same polarization. So, to overcome this problem to certain extent, we are going to be using a technique called as intensity modulation technique. We use a intensity modulation technique. By using intensity modulation technique, what happened is, now your signal was carried with the help of intensity modulation. Therefore, there is no question of having a problem at the detector side also. Detector is also become insensitive towards to the phase and also on the polarization. Detects the signal and gives the output value. This is what happens with your polarization in your optical communication system. For example, fiber maintains the symmetry, this much discussion is not required, because the same symmetry is maintained by the complete fiber manufacturer companies. Then what happened means your fiber is going to be have a circular symmetry, so that it is going to be pass the light with polarization. Without having that symmetry only, with the polarization is not maintained. One of the technique to maintain the polarization is intensity modulation. By using intensity modulation, your photodetectors are possible to detect the signal, and the photodetectors are become insensitive towards to the phase changes. They are not sensitive, they become insensitive to the phase changes. So, by this what happened means, you are going to be getting the polarization to certain extent. To know up to what extent that polarization has comes for your signal by using intensity modulation can be find out by using the fiber birefringence. Can be find out by using the fiber birefringence. It is called as fiber birefringence. The name itself indicates bi stands for two, refringence. What is the meaning of refringence in the sense means one single light wave splitting into two rays. When the light is coming with single ray split into two rays is called as birefringence. That is called as birefringence. So, I can explain the concept right now called as birefringence concept, that is called as fiber birefringence concept. भैया थोड़ा ध्यान से सुनो. I explain the problem because of not having circular symmetry, don't have a polarization. To certain extent polarization maintained by intensity modulation, but that is can also be measured with the help of fiber birefringence. Your fiber birefringence is uses for, your fiber birefringence is uses for completely to know the polarization offered by the optical fiber cable. Optical fiber cable. I will explain the concept. Please all of you check this one. भैया ये हमारा सिंगल मोड फाइबर है. सो क्लास में स्टडीड. डायमीटर ऑफ कोर इज वेरी लेस. एंड ये हमारा मल्टी मोड फाइबर है. सॉरी, दैट इज कोर एंड क्लैड ऑफ ए फाइबर है. So one typical mode is present. Such mode which is typically present is called as HE11 mode, which is called as HE11 mode we are having. It is called as HE11 mode we are having. So this is what we call it as our HE11 mode we have. So try to understand one simple part here. This is called as HE11. So if your fiber is going to be maintain the symmetricness, circular symmetry, the light ray will travels with uniform velocity throughout the length of the fiber. So there is no issue if it is going to be having a circular symmetry. But what happened is, because of non-symmetricness and because of external stress and strain, because of fiber bending, we have a problem called as, so because of the geometric imperfection of the core, because of stress and strain on the fiber, internal and external stress on the fiber, and fiber bending, what happened is this mode cannot be travelled with as a HE11 mode. It degenerate into two modes. Bhaiya, please concentrate. It degenerated into two modes. Degenerated into two modes. Those modes are called as HE11 mode of X and it is called as HE11 of Y. It is called as HE11 of X, another one is called as HE11 of Y we are having. So I hope everybody in the class understood this. What is these modes? Because it contains those two modes here, the two modes will going to be travel with the uniform velocity. But because of the imperfection in the core geometry and due to the internal and external stress on the fiber and the bending of the fiber, will change this into two degenerative modes, HE11X and HE11Y. This HE11X and HE11Y will travel with different velocities, creating a problem called as polarization mode dispersion. Understood now? Because HE11Y, HE11X will travel with different velocities. They have a modes due to the polarization. These are called polarization mode, which is said to be called as the dispersion. So polarization mode dispersion we are having. So after talking about this one, that is a polarization mode dispersion. So understand clearly such that in this polarization mode dispersion we are having. First point we can see here is, so HE11 mode and HE11X is going to traveling with two different velocities. We can tell that with the help of, when HE11 mode is traveling with a different velocity, it is having a different propagation constant beta x. When He11y is moving with a different velocity, it have a different propagation constant called as beta y. So beta x is moving faster means we can beta x is the faster mode, and beta y is moving slower means beta y is called slower mode. By this what happened is they both don't travel with same velocity, they travel with different velocity. Why? They got a mode degenerated from the your fiber of single mode, making into birefringence. See, birefringence, one wave, one mode, light ray or particular mode, single mode is now make into two modes in two nominal directions. One is called He11x, other one is called He11y. So that impact is calculated by using the fiber birefringence. Already I told to you, whenever we have a polarization is failed, it can be measured with the help of fiber birefringence. So now I am going to be explaining you about the definition of the fiber birefringence. Dekho bhaiya, I am talking about the birefringence given as BF. Your BF is nothing but an beta x minus beta y divided by 2 pi by lambda is the value we are having, which is said to be called as the birefringence formula, also called as fiber birefringence. It is the fiber birefringence. What is beta x and beta y? The beta x and the beta y is the nothing but a different propagation constants of He11x and He11y respectively. I hope everybody in the class understood this. Okay bhaiya, please see here one more point, that's point number 2. If beta x and beta y travels with the same velocity, means the propagation constant of He11x and He11y is same, then beta x and beta y remains same, then what happens is the difference of that become equal to 0 bhaiya. There is no fiber birefringence, the two modes are traveling with the same velocity, uniform velocity we are having. So this is what said to be called as the fiber birefringence. If they move with different velocities, you can use that parameter to find out. Next one is called as coherence length. Please observe here, it is called as coherence length we are having. Your coherence length was going to be given as LC bhaiya. The coherence length in the sense means the amount of length that the two modes will travel with the same phase is called as coherence length. He11x and He11y traveling with the same phase for some distance, such distance is called as coherence length. What's the meaning of that one is? Whenever the fiber is going to be launched into a fiber because of geometric imperfection, no bending, they will travel for some distance with the same velocity, uniform velocity. After some distance, because of geometric imperfection in the core, the two modes will degenerate and travel with different velocities. Now see here, before that how much distance they travel along with together along the fiber is called as coherence length. The coherence length was given by a formula called as lambda square divided by BF into delta lambda. Bhaiya, delta lambda is called as the line width. Already we studied in the classroom this concept. Such line width is equal to lambda 2 minus lambda 1, that is line width of source. So line width of source we are calling it as. Okay. So this is about the coherence length. Next one is called as beat length bhaiya. What is the beat length? I will explain. LB. Up to now I told this point. The length the two fibers travelled together is called as coherence length, it's same phase. The length that after separation, the two fibers are going, the two modes are going to separate right now. the length that travelled by the, okay, two degenerative modes. By understood na? See, I am explaining once again. The length that travelled by the two degenerative modes to have a phase difference of 2 pi, to obtain a phase difference of 2 pi is called as your beat length. I explain once again, please see here. The length that two degenerate modes travels to have a phase difference between them as 2 pi. To have a phase difference between them as 2 pi is called as beat length. That is called beat length by A. Beat length is given as formula given as lambda divided by Bf. Bf is fiber birefringence. Now it is calculated. So lambda divided by Bf is equal to beta x minus beta y divided by 2 pi by lambda. So we can write this value is equal to lambda into 2 pi by lambda, beta x minus beta y, lambda cancel. Then we can tell that LB is equal to 2 pi whole divided by beta x minus beta y. This is called as your beat length. So that is called as your beat length. So this is what said to be called as LB. LB is equal to 2 pi divided by beta x minus beta y we are having. So this concept is called as fiber birefringence. Because of non-symmetricness, your fiber is split into two modes, travel with two different constants. So beta x minus beta y is equal to 2 pi by lambda. Coherence length, the amount of length they travel with the same phase is coherence length. The length that the travelled by the light waves to have a phase difference of 2 pi is called as, to obtain a phase difference of 2 pi is called as beat length. So after this we can tell about the bandwidth. Please copy this part. I will explain the remaining things after this. Complete copying. Right. Right on the see here, I will explain the remaining two things. If anybody copying, please copy from here onwards. Yeah, see here. Next one is called as 3 dB bandwidth. Also called as half power bandwidth. It's called 3 dB bandwidth or half power bandwidth. The bandwidth B is given by a formula called as 0.9 divided by delta T into L. What is delta T? Delta T is called as intermodal dispersion. Is called as intermodal dispersion. Already we studied. Intermodal dispersion. Here that delta T is also called as polarization mode dispersion also. Delta T is called as polarization mode dispersion also. Okay, which is delta T is called polarization mode dispersion also. So this is called as intermodal dispersion, or it is also called as polarization mode dispersion. Polarization mode dispersion we are having. Okay, so polarization mode dispersion we are having. So next one is called as bit rate. Talking about the bit rate. Bit rate is given as maximum bit rate, that is called as the maximum bit rate. Your maximum bit rate is given as Bt max. Bt max is called as the maximum bit rate. Maximum bit rate is equal to bandwidth B upon 0.55 we are having. That is nothing but an 0.9 divided by delta T into L into 0.55 we are having. So 0.9 into delta T into L into 0.55, which is called as maximum bit rate we are having. So this is completely a concept of your attenuation bhaiya. A very big concept present in the entire optical communication system is this concept only. It takes more amount of time, you observed it or not. For last 3 days we are studying attenuation only. Okay. So this is completely about the attenuation. So please make a note of this one. I will tell the points to you and we can solve the numericals based on all these concepts. Okay. So one student asked a doubt such that sir, why you take this lines as 2 lines? Nothing else. If it is traveling in this direction, then we can have in this direction you are going to be having the HE11Y and HE11X is present. For example, the HE11X is travel in this direction, then we can have in this direction we will have HE11Y will be present. That is why represented by 4 lines. Strictly speaking, we have only 2 lines. Those are orthogonal modes, Nana. One is moving X direction, other moves in the Y direction. They are orthogonal to each other, na. That is why. Okay. So why you draw like this means that is the justification what I gave to you right now. ठीक है ना? Anuj Bhaiya, I hope your doubt is clear. Soumya and Radhika, thank you for the message. Sagar, you are most welcome. I think it's clear for you. It's crystal clear. Once you complete writing, you please put a message to me, guys. I will just tell the points to you. We are running out of the time. I don't understand why this 4 hours is runs very fastly. इतना फास्ट चल गया 10 होने के वे Yeah, basically my Hindi is not that much good, AR Singh. I tried so many number of times to speak in good Hindi. I am learning, but there is no perfect guidance for me to learn Hindi. When I came for the classes, I will speak little bit Hindi, but major problem is when I came to the classes, I learn little Hindi, but when I go to my hometown, once again, no one will speak Hindi there. We all communicate in Telugu language only. That's why we speak Telugu there, and mother tongue is Telugu itself. Then I forgot the entire Hindi, and I come here, I don't get the flow. That's why I am always trying to search for the words when I am speaking Hindi, and my grammar is very poor. I don't know what is kya hota hai. I don't know the grammar also, strictly speaking. Thank you, Anuj Naik, for your compliments. Class seems to be like only 2.5 hours. Okay. Kushbu, I have a class from morning 8 o'clock to night 10 o'clock. I am not free in the afternoon to take a class for you in the afternoon. Okay. I have to take a long class, and I am working from daily 14 hours from morning to up to evening, up to night. Okay, right. Radhika Devi, thank you for the message. Please write down. Bhaiya. Yeah, I forgot to explain that repeaters. I forgot to explain you the repeaters, Bhaiya. We just go for after repeater, after couplers we start this one birefringence. I will explain the repeaters also to you. Don't worry. Prajakta Niranjan, thank you for the doubt, and I will definitely explain the repeaters to you. Please, Bhaiya, please write down the points for this one. I will explain the repeaters. Write down first point. Cylindrical optical fibers. Cylindrical optical fibers do not generally maintain the polarization state of a light. Cylindrical optical fibers, I am repeating once again, cylindrical optical fibers do not generally maintain the polarization state of the light input. Maintain the polarization state of the light input. For more than a few meters. For more than a few meters. And for many applications, involving optical fiber transmission. For many applications involving optical fiber transmission. Some form of intensity modulation. Of the optical source is utilized. Intensity modulation of the optical source is utilized. Bhaiya, I explain the first point to you in polarization. See, I am explaining the points to you. So, explain the first point to you in polarization. Clear na? Right. In polarization. Second point, the optical signal is detected by a photodiode. The optical signal is detected by a photodiode, which is insensitive to optical polarization, or phase of the light wave, within fiber, within the fiber. Next point, point number 3. The fibers are single mode. And the maintenance of the polarization state is described in terms of fiber birefringence. Maintenance of the polarization state is described in terms of fiber birefringence. Okay, right. Please put the heading as fiber birefringence, all of you. Please put the heading as fiber birefringence. So, put the heading as fiber birefringence. Okay, fiber birefringence. Write down first point, single mode fibers, with nominal circular symmetry about the core axis, allow the propagation of two nearly degenerate modes, with orthogonal polarizations. Right. They are He11X. Next point, Nana. They are He11X and He11Y modes where the principal axis X and Y are determined by the are determined by the symmetry elements of the fiber cross section. So both polarization modes propagate with identical velocities. Okay, propagate with identical velocities. Right. Next one. Next one is, right on the next point, manufactured optical fibers however exhibit some birefringence due to difference in core geometry comma internal and external stress and fiber bending full stop. Next point, Nana. Due to this the modes have different propagation constants. Beta x and beta y, which are dictated by the fiber cross section. Okay, write down the birefringence BF for the fiber is, next point, Nana, the birefringence BF for the fiber is write down the formula. BF is equal to beta x minus beta y divided by 2 pi by lambda. BF is equal to beta x minus beta y divided by 2 pi by lambda. 2 pi by lambda. Right. Next point. The birefringent coherence is maintained. Next point. The birefringent coherence is maintained over a length of fiber is coherence length over a length of fiber is coherence length write down the formula. LC is equal to lambda square divided by BF into delta lambda. Lambda square divided by BF into delta lambda. BF into delta lambda. Right. Next point, the characteristic length LB, L capital B nana, the characteristic length LB for this process corresponding to the propagation distance, for which 2 pi phase difference accumulates, for which 2 pi, 2 into pi phase difference, 2 pi phase difference accumulates between the two modes is known as the beat length. Between the two modes is known as the beat length. Okay. Write down LB is equal to lambda divided by BF, lambda divided by BF. So write down that is equal to 2 pi upon beta x minus beta y, that is equal to 2 pi upon 2 pi divided by beta x minus beta y, okay. The 3 dB bandwidth, next point, the 3 dB bandwidth beta is equal to, the 3 dB bandwidth beta is equal to, sorry, B, the 3 dB bandwidth B, capital B nana, capital B is equal to 0.9 divided by delta T into L, 0.9 divided by delta T into L, right. the last point for the today's class. The maximum bit rate for digital transmission in relation to PMD is digital transmission in relation to PMD. What is PMD? Polarization mode dispersion by in relation to PMD. PMD means polarization mode dispersion. PMD is BT max, capital B nana, BT max. See maximum bit rate notation, we use BT max. BT max is equal to capital B divided by 0.55. Capital B divided by 0.55. Right. That is equal to, what is the formula we studied in the classroom? 0.9 whole divided by, write down Nana, delta T into 0.9 whole divided by delta T into L into 0.55. Delta T into L into 0.55. What is delta T? Delta T is polarization mode dispersion. And what is L? L is called as length of the fiber. L is length of the fiber by L is length of the fiber. The L in bandwidth formula is also length of the fiber only. L is length of the fiber. Okay students, so that's all for the today's class. So tomorrow's class I will explain you about the repeaters. So I am writing here, see here. I will explain the repeaters. Once again thank you for Prajakta for asking such a doubt. Why coupling loss is not present in the repeaters? No, it is present in the repeater also. We are talking about the repeaters. Even though you study in the communication repeaters, I am explaining you once again entire repeaters here, because some students are not complete communication systems. So whatever it may be, I will explain from my side to you. So how that repeaters are working and what is the functionality of the repeaters and what are the different types of repeaters, error occurs in the repeaters, and one more thing, how the repeater selection has to be done. So based on which parameters the selection is to be done, and at last the importance of your repeaters in WDMs and the importance of the disadvantages of repeaters. We will see all those things in the tomorrow's class. Okay, so good night, stay blessed, and Jai Hind.